So far, all the indices we've looked at have been positive. Consider the following fraction problems. Let's see how they can be simplified. If we look at 2 cubed divided by 2 to the power 4 in expanded form, we would get this. If we simplify this by cancelling, we can see that we end up with 1 in the numerator and 2 in the denominator, or a half. But we know if we're dividing terms with the same base, we can subtract the powers. So 2 cubed minus 2 to the power 4 would be the same as 2 to the power 3 minus 2 to the power 4, or 2 to the minus 1. We've solved the same problem in 2 different ways, which shows us that 2 to the power minus 1 is the same as a half. And while there's no power written on this 2, it's actually 2 to the power 1. Let's look at this next problem. 7 divided by 7 cubed. In expanded form, it would look like this. And if we simplify by cancelling, we find that we end up with 1 over 7 squared. If we use our index law to simplify the problem, it would be like 7 to the power 1 divided by 7 to the power 3, or 7 to the power 1 take 3, which would be the same as 7 to the minus 2. We can see in this next problem that 7 to the power minus 2 should be the same as 1 over 7 squared. So it seems that a negative power is the same as 1 over that value to the positive power. So we can see 7 squared here in the denominator. If we look at the previous problem, 2 to the power minus 1 became 1 over 2 to the power 1. Let's try a to the squared divided by a to the 5. If we look at this in expanded form, and we cancel, we end up with 1 over a cubed. If we use the index law to solve this problem, it would be the same as a to the power 2 minus 5, and this would equal a to the power minus 3. And we can see that this is the same as 1 over a to the power positive 3. In general, if we have any value raised to a negative power, it's the same as 1 over that value raised to the positive power. What about if we have 1 over a value to a negative power? Well, we know that any value to a negative power is the same as 1 over that value to the positive power. So in fact, this fraction would become 1 divided by 1 over a to the power n. And we know that when we're dividing by a fraction, we invert the second fraction and we change the divide to a multiply. So this is the same as 1 times a to the power n over 1, or a to the power n. So in fact, we know now that any value to a negative power is the same as 1 over that value to a positive power, and that 1 over any value to a negative power is the same as that value to a positive power. Essentially, if you have a value raised to a negative power in the numerator, you could flip it to the denominator and make the power positive. Or, if there is a value in the denominator with a negative power, you could flip it to the numerator and make the power positive. What if we have a fraction raised to a negative power? Well, we can use the same rule that says anything to a negative power is 1 over that same value to a positive power. And we can rewrite this fraction as 1 over a divided by b all to the power positive n. We know that when we have a fraction inside a bracket, that the power outside applies to everything in the bracket. So this can be rewritten as 1 divided by a to the n over b to the n. And using our fraction skills, when dividing by a fraction, we invert the second fraction and we change the divide to a multiply. So in fact this becomes 1 times b to the n over a to the n, which is the same as b to the n over a to the n. And this would be the same as b over a to the n. So in general, if we have any fraction raised to a negative power, we can invert the fraction and make the power positive. Using these two rules, we can simplify the following problems. We know that anything raised to a negative power is the same over that value raised to a positive power. So it makes 3 to the power minus 1, same as 1 over 3, or a third. Similarly, 2 to the power minus 3 would be 1 over 2 cubed, or 1 over 8. If we have a half raised to the power negative 1, that would be the same as 2 over 1 to the power 1, or 2. And for 3 divided by 2 raised to the power minus 3, that would be the same as 2 thirds raised to the power 3, and when there's a power outside the bracket, it applies to both the numerator and denominator of the fraction inside the bracket. So this would be the same as 2 cubed over 3 cubed, or 8 over 27. To simplify each of the following, we need to look at the powers and think very carefully about what they apply to, especially when there's brackets. In this first example, the power of minus 1 only applies to the x and not the 4. So this would be the same as 4 times 1 over x to the power 1, or 4 over x. You can see that the x to the power minus 1 has simply been moved to the denominator, and the power of minus 1 changed to a power 1. If we look at this next example, we have 3x raised to the power minus 3. So we know that anything raised to a negative power is the same as 1 over that value raised to a positive power. Now we use our other index law that says when there are more values in the brackets, the power outside applies to everything in the bracket. So it becomes 1 over 3 cubed x cubed, or 1 over 27 x cubed. Similarly, xy all to the power minus 1 becomes 1 over xy. And in this last example, there's a negative power inside the bracket as well. In this case, we have two options. One is to take the power of minus 3 into the bracket first, or make the power positive by writing everything as 1 over 5x to the minus 2 to the power 3. If we evaluate this way first, that would be the same as 1 over 5 cubed x to the minus 2 times 3, or 1 over 125 x to the power minus 6. To write this with a positive power, we need to remember our other rule, which says that if we have 1 over any value to a negative power, it's the same as that value raised to a positive power. So to simplify this so it has no negative indices, it's the same as x to the power 6 over 125. The second way to evaluate this problem is to take the minus 3 into the bracket first. So we know that when there's a power outside the bracket, it applies to every value inside the bracket. So this becomes 5 to the power minus 3 x to the power minus 2 times minus 3. which is the same as 1 over 5 to the power 3 times x to the power 6. If we multiply the numerators, 1 times x to the power 6 is x to the power 6, and in the denominator 5 cubed is 125. So we get the same answer both times. To simplify 7 to the power minus 1, it's simply 1 over 7 to the power 1, or 1/7. 3 to the minus 2 becomes 1 over 3 squared, which is 1 over 9. Here the power of minus 2 applies to the minus 4, so this becomes 1 over minus 4 squared, and we must keep the brackets, because minus 4 squared is actually 16. So the final answer here is 1/16. In this case, the power of minus 2 applies to the 4 and not the negative. So this would be the same as minus 1 over 4 squared. And so this expression evaluates to minus 1/16.